Welcome to the final part of our lecture on exception handling in C#. At this stage, you've seen how to detect, handle, throw, and rethrow exceptions. In this segment, we'll dive into the exception class hierarchy, explore common system and I/O exceptions, and wrap up with practical guidelines and best practices for writing robust, maintainable applications. All exceptions in C inherit from the base class system. Exception, the Common Language Runtime (CLR), throws exceptions derived from system exception for system-level failures. You can catch both base types and specific derived exceptions, depending on how granular your error handling needs to be. So, here are some of the most frequent runtime errors: index out of range exception, trying to access an invalid array index; null reference exception, calling a method on a null object; divide by zero exception, integer division by zero; out of memory exception, the system runs out of memory; stack overflow exception, too much recursion. These are all thrown by the CLR when it detects unsafe or incorrect behavior. You can simplify error handling by catching exceptions with their base class. For example, catch exception X will handle any exception that derives from exception. This is useful for generic fallback handling or logging. Just remember, always catch specific exceptions first, then use a general block. Historically, application exception was used for user-defined exceptions. However, Microsoft now recommends deriving custom exceptions directly from exception to avoid confusion and simplify the hierarchy. In Java, some exceptions are checked, meaning the compiler forces you to handle them. In C#, all exceptions are unchecked. That means you're not required to catch them, but you should, especially when dealing with I/O, parsing, or external resources. Let's review some essential exception types: divide by zero exception, index out of range exception, invalid cast exception, null reference exception. These represent core issues in program logic and should always be handled or prevented with good design. File and stream operations throw these exceptions: directory not found exception, end of stream exception, file not found exception, file load exception, path too long exception. These help you pinpoint exactly where and why an I/O operation failed. Here's a broader look at system-level exceptions: argument exception, format exception, overflow exception, rank exception, null reference exception, I/O exception. These are the building blocks of defensive error handling in .NET, and they represent violations of language or runtime rules. Beyond the core libraries, you'll encounter exceptions from specialized namespaces: invalid project file exception in build tools, isolated storage, exception for secure storage, SUDS parser exception in remoting services. These demonstrate how .NET's exception system extends across its entire ecosystem. Here are your golden rules. Use exceptions only for unexpected or exceptional conditions, not normal control flow. Always catch specific exceptions first. Use finally blocks or using statements for resource cleanup. And always log exceptions to help with debugging and support. Resource management goes hand in hand with exception handling. Always release resources as soon as they're no longer needed. Use finally to guarantee cleanup. Avoid holding references to unused objects. They may delay garbage collection and increase memory usage. Let's recap what we've learned. Use try-catch finally to handle exceptions gracefully. Catch the most specific exception types applicable to the situation. Use custom exceptions to express domain-specific errors. Always clean up resources, preferably in finally blocks or using. These practices form the backbone of robust, professional C# applications. Exception handling is not just about preventing crashes. It's about creating resilient, predictable, and user-friendly software. Used correctly, exceptions clarify your code, simplify error tracking, and protect users from experiencing failure directly. Always code defensively, handle exceptions transparently, and ensure resources are released properly. This concludes Chapter 7 on exception handling in C#. Over 5 detailed parts, we've explored everything from basic syntax to advanced exception strategies, file I/O protection, rethrowing techniques, and the structure of .NET's exception hierarchy. With these tools, you're now equipped to write C# programs that don't just work, but fail gracefully, recover intelligently, and communicate clearly when something goes wrong. In our next lecture, we'll move into event-driven programming, covering delegates, events, and multicast behavior, paving the way for dynamic, interactive applications.